All right. In this video, we'll be solving more questions on regression analysis, and again, we'll be looking into some exam possible questions as far as regression analysis is concerned. Please take note of that. But before we do that, let's try to take the definition of regression analysis. Okay, please. All right. Regression analysis can be defined as the functional relationship between the dependent, please take note of this, between the dependent variable and independent variable. Okay, between the dependent variable, that is, I will say x, I will say y, and independent variable what? S. Please take notes. Okay, let's look up here, please. Now, this dependent variable here, we can also call dependent variable. Please take note of this. We can also call dependent variable to be respond variable. We can also call this respond variable. Please take notes. Now, this independent variable, we can also call it explanatory variable. Okay. Now, either you call this dependent variable or what? Response variable. Either you call this independent variable or what? Explanatory variable. Okay. Now, let's try to look into the types of regression analysis. Please write. Number one, simple or linear regression analysis. Number two, multiple or compound regression analysis. Please take note. Okay, now we are going to treat this, okay, and also treat this, but mostly in this video we are going to treat much on what? Simple or linear regression analysis. Okay, please write simple or linear regression analysis. Okay, let's continue on simple or linear regression analysis. Okay, now class, as the name implies, simple or linear, it means that it will take the graph of what? The equation of what? Linear or straight line equation. Please take note. Now, what is the equation of linear? What is the equation of linear? Linear. We say that the equation of linear is said to be y is equal to ms plus what? C. Okay. Now let's try to deal with this guy here before we know the formula for simple or linear regression analysis. First of all, this y here, this letter here, that is the subject, is what? The dependent. Please take note. Any letter that is the subject is subclass the dependent, while this s here is subclass independent. Please take note. While the coefficient of this independent is subclass slope, we call this guy here slope. Please take note. We call this guy here what? Intercept. Okay. Now let's apply the same thing here. Now, since simple or linear regression analysis is also taking the equation of a straight line, it means that I will write this to be y is equal to, for me to say m, I will say beta 1 of s plus what? Beta naught. If there is any error here, I'll put what? E, like this. Please take note. Now, where we all know that y here, the letter that is standing as the subject is what is class? Dependent. While this s here is class independent. Please take note. While this beta 1 here, we call this beta 1 is said to be regression coefficient. Please take note. Regression coefficient. That is beta 1, beta naught, and beta 1 is said to be regression coefficient. Please take note. Why this E here is said to be disturbance or random error. Please take note of this. Okay. Now remember that this Y here is said to be a dependent variable here. This S here is subclass independent variable. Why beta naught and beta 1 is subclass regression coefficient. Why this E here is subclass disturbance or random error. This is what you should know here. Whenever you are given a equation and there is no E, listen to me please. Whenever you are given an equation and there is no error mentioned, that means that this equation can also be written as Y is equal to, that means I'll have to eliminate this guy here. Y equal to beta 1 of S plus what? Beta naught. Please take note of this. So if there is nothing like error there in that equation, it means that our regression, the simple linear regression analysis equation will be Y equal to beta 1S plus what? Beta naught. Okay. All right, class. This is what you should understand here. Of course, this from this equation of a straight line, we're able to form the formula for what? Simple linear regression analysis. And I told you guys about this E here, that the E subclass disturbance or what? Random error. But if there's nothing as error there, it means that the equation of simple or linear regression analysis should be what? Y equal to beta 1S plus what? Beta naught. I'm going to eliminate this guy here totally. Please take note of that. Okay. Now, but in terms of listing, this equation here is what we call regression equation. But we can't use regression equation to solve any this particular expression here. What do we use in solving simple regression analysis here is what? Estimation equation. And what is the estimation equation here? We say that it's said to be the estimation equation is said to be, okay, we are going to take it from this guy here, that is Y bar. I'm going to tell us what Y bar is. It's equal to beta 1 hat, what again? S bar plus what? Beta naught hat. Okay. Now where Y bar and S bar is said to be what? Mean of Y and S. Please take note. So Y bar and S bar is said to be the mean of what? Y and S. Please take note. Okay, the next one here is said to be beta naught hat and beta 1 hat. This is said to be estimation. This is said to be estimation parameters. Please take note. This is said to be estimation parameters. Okay. Now, but look up here, please. Look up here, please. This one here is used, this equation here is used to show the relationship between S and Y. While in solving, in calculating your parameters, we use this estimation equation. Please take note. Now, understand this. This Y bar here and S bar is said to be the mean of S, Y, and S. Please take note. I'm going to explain this later. Now, this beta naught hat and beta 1 hat is said to be estimation parameters. Class, if this guy is given, this Y bar is given, and this S bar is given, and again, this guy here is given, can I be able to calculate this guy? Yes. I will just make this guy what? The subject. Now, this beta 1 hat like this has a formula. What is the formula here? The formula is said to be n sum of SY minus sum of sum of Y. Okay. Okay. Now, what is that? Now, this is sum of SY minus, scatter this guy here, scatter the summation here. This will be sum of S, sum of Y over, okay, over n sum of S squared minus sum of S or what? Squared. Okay. Now, this is the formula we use in calculating this beta 1 hat. Please take note. So this guy, if this guy is given, which I told you guys, this guy is given, and this guy is the formula here. It is given to us. To calculate this guy means that I have to make this guy what? The subject of formula here. Class, let's solve question 1 here to understand everything about what? Linear or simple regression analysis. Please, example 1, please. In an experiment, various doses of a poison were given to groups of 25 mice, and the following results were observed. Okay, these are the results here. The dose is standing as S. This S milligram is just the unit of the dose, while the number of deaths is standing as what? Y. Please take note. I say obtain the mean S bar and Y bar. Please take note. S bar and Y bar simply means mean of S or mean of what? Y. Please take note. And we know that the numbers for S is said to be 4, 6, 8, 10, 12. Now, what is mean here? Mean is said to be the sum of the sum of the numbers divided by its frequency. Am I correct? So that means our S bar here will be equal to, look at S here, the values of S, 4 plus 6 plus 8 plus 10 plus 12 divide by, this is 1, 2, 3, 4, 5. Divide by what? 5. Okay. Now point your calculator. What is the answer? 40 over 5, which is going to give us this class 8. You get? Now let's get Y bar. Now Y bar is going to be 1 plus 3. Please take note. Plus what? 6 plus which of them? 8 plus what? 16 over what? 5. Please take note. Okay. Now let's punch our calculator here. That is 34 over what? 5. Okay, what is the answer here? 34, punch your calculator here. 34 over 5. What is the answer? 8. 6 point what? 6.8. Okay, we have this to be 6.8. Okay. Now we have calculated this guy here. We have calculated this. So let's try to find it. They say find beta naught and beta 1 there. Class, we said that in finding most of the parameters in terms of a regression equation, that is maybe beta naught or beta 1, we use estimation equation. Please take note. In finding all regression parameters, we use what? Estimation equation. And what is estimation equation here? Using estimation equation, we have this to be Y bar is equal to beta 1 hat S bar plus what? Beta naught hat. Please take note. So class, we know this already. We know this already. It's now left for us to calculate for this class beta 1 hat. And we know that beta 1 hat, please take note. We know that beta 1 hat is said to be n sum of s y minus sum of s sum of y over what? N sum of s squared minus what? N sum of s all squared. Okay. Now from this, listen to this. From this particular formula here, we can now know what we are going to do in this table here. Remember that we don't have anything like sum of sy in this table here. We are going to form that. We don't have anything like sum of s here. We don't have anything like sum of y here. We don't have anything like this m here means the frequency of s or y, which is going to be 1, 2, 3, 4, 5. Please take note. Okay. Now we don't have anything like sum of s squared. Please take note. So how do we get that? Now if I want to get sum of y there, I have to structure this table here. So sum of sy means the total of sy. Please take note. Now sum of s means total of what? S. Sum of y means what? Total of what? Y. Sum of s squared means what? Total of what? S squared. Okay. Now let's try to restructure this particular table so I can get all the summation and also all the variable here. Okay. When you do that, we are going to have something like this. Okay. Now let's get the new table here. But understand that the new table here will depend on what? On the parameters here. Please take note. Okay. But first of all, let's get the initial table. Remember that in the initial table here, we have s, we have y. Okay. Now let's go. Class, what are the values of s, please? 4, that is 4. Yes. What again? 6. Yes. 8. Yes. 10. Yes. 12. Okay. Now let's get the values of y. 1, yes. 3, 6, 8, 16. Now if you look here, the total of s will give us sum of s. So let's total this. The total of s. Okay. Now let's total this. This total of s, please, class. This plus this plus this plus this plus this. What is the answer, please? 40. Okay, we have this to be 40. Please take note. Now let's go. This plus this plus this plus this plus what is the answer? That is 34. That is sum of y. Sum of y is said to be 34. Okay, 34. Okay, sorry. Is said to be 34. Okay. Now please understand this, that our structure of table here depends on the parameter here. We have gotten sum of s, sum of y. So now let's go to sum of sy. Before I get sum of sy, I have to get sy first. Now what is sy? Sy means s times y. Okay. Sy means s times y. Okay. Now let's get this. S times y means this times this. What is the answer? 4. All right. Now 6 times 3. What is the answer? 18. Please take note. Let's go. 8 times 6. What is the answer, please, class? That is 48. 10 times 8. What is the answer? 80. 12 times 16. What is the answer? 192. Okay. Now that means let's get the sum. Sum means the total of sy. Now sum of sy. Sum of sy. What is the result, please? Let's total this. That is this plus this plus this plus this plus this. What is the answer, please? That is 342. Okay. Now the next thing here, class. Let's go back again to get the next. The next thing here, subscribe to get what? S squared. Now let's get s squared here. S squared. So I should square the value of s here. Please take note of this. Okay. Now square this. What is the answer? 16. What about this? 36. What about this? 64. What about this? 100. What about this? 124. Okay. Am I correct? 124, right? 12 times 12. 144. Sorry, yeah. 144. Okay. Now that means we have gotten this. Now the sum of s squared will be equal to, yes, point your calculator. The sum of s squared is what? This plus this plus this plus this plus this. What is the answer? 360, something like that. Just point your calculator. That is 360. Okay. Now class, that means you can easily calculate this guy here since all the parameters are known to us. That means our beta, please take note of this, our beta hat bar is said to be n is the frequency of s and y. That is, let's count 1, 2, 3, 4, 5. We place 5 here, class. Now let's go here. Now sum of sy, sum of sy, sum of s squared is what? 342 minus, the minus is this guy here. Now sum of s, what is my sum of s here, this class? 40. Okay. Now sum of y, okay, let's replace. Sum of y is what, class? 34. Please take note. Over, now this is 5 into sum of s squared is what? 360 minus sum of s. What is my sum of s here, this class? 40 or what? Squared. Okay. Now class, let's point the calculator here. That is beta 1 hat will be equal to, let's get the numerator first. This times this minus 40 times 34. What is the answer? This times this times this minus 40 times this. 1710 like this. Over, okay, minus, okay, minus 1710 minus this 1360 like this, divide by, okay, this guy here. What is the answer here? Sorry, 1800 minus this will be 1600. Am I correct? Okay. Now beta 1 hat, just give me the answer here. That is total answer here. This minus this over this minus this. What is the total answer here? That is 7.5. The answer will be 7.5. Just let me get the answer, please. $1.75. Okay, I have this to be 1.75. Thank you for this. Okay, so we have calculated, listen, we have calculated for beta 1 hat. Please take note. Now remember that this other guy here is giving, this guy here is giving, and this one is not giving. So to calculate for beta not hat, be very simple, right? We are going to make what? Beta not hat the word subject of formula here. Okay, class, let's get this right. We have calculated for y bar, that is the meaning of y. We have calculated for s bar, that is what? The meaning of s. We have calculated for beta 1 hat. Remember? So our intention here to complete the parameters in terms of estimation equations, what? Beta not hat. So using the same equation here, that is y bar is equal to beta 1 hat s bar plus what? Beta not hat. Please take note. So this guy here is giving. What is the value of y bar, please, class? That is 8. Am I correct? Is equal to, is it 8? The value of s bar divided by 5 here will give us 8, Abi? Yeah. Okay, this will give us 6 point something. We got that 6 points. That is 6.8, right? That is 6.8. We got this as 6.8. Is equal to beta 1 hat is what? 1.75 into s bar is obviously plus 8. Please take note. Plus what? Beta, sorry, plus beta not hat. Okay. Now, class, our intention here, remember, is to make this beta not hat the subject. So let's punch our calculator. 6.8 is equal to 1.75 times 8. That is 14. Plus beta not hat. Let's make this the subject. So anything about number should be shifted one side, while the one that's not of number should be shifted one side. So this will be 6.8 minus 14 is equal to beta not hat. Okay, punch your calculator, please. Beta not hat is equal to minus what? 7.2. Okay. Now the point here is, remember, we are not asked to, remember, listen, please. Listen, we are not asked to calculate for beta 1 hat, nor are we asked to calculate for beta not hat. We are asked to calculate for beta 1 and what? Beta not. Now, what is the relationship between beta 1 hat and beta 1? What is the relationship between beta not hat and what? Beta not. So this is what you should know here, that beta 1 hat is the same as class beta 1. Please take note. And again, that beta not hat is class the same as class beta not. Okay. So anything you calculate for this one here is said to be estimation parameter, while this one here is said to be what? Regression coefficient. Okay. Please take note. Okay. That means let's find this. Our beta 1 here will be equal to this guy, which is class 1.75. Now our beta not here is said to be this guy, which is class minus 7.2. Okay. Now this is our beta 1 and what? Beta not. Okay. Now what is the next question here? The next question here is for us to represent the line of best fit equation, right? Now how do we do that here? We have to substitute the values of beta 1 and beta not into the regression equation. Now what is the regression equation here? It's said to be y is equal to beta 1 s plus what? Beta not. Please take note. This is called regression equation. Please take note. So class, y is not given to us. Please take note. Is equal to beta 1 is what? 1.75 of what? S. What is our beta not? This is plus into beta not is what? Minus 7.2. Please take note. Okay. Now this will be y will be equal to class 1.75 of s plus times minus is what? Minus 7.2. So this is our line of best fit equation here. But this is what you should understand under the equation of line of best fit. What is the slope here? What is the intercept? Now they might give you some regression model equation. This is our regression model equation, or line of best fit equation, or regression equation. Listen, it can either call this equation here that relates s and y only to be regression equation or line of best fit equation, or you can call it what? Regression model equation. If you are given regression model equation like this, and you are asked to find the slope or the intercept. How do you find this? We are going to relate this guy here with the equation of what? Straight line, which is said to be y is equal to ns plus what? C. Now on that comparison here, this is y, this is y. Now this is s, this is s. We say that the coefficient of s is what slash slope. That means my slope here is what slash 1.75. All right. Now apart from that, this is plus, this is minus here. Now this side here should represent what this class? Intercept. So taking your intercept here, class, whenever you are taking a value, if that value is positive, you can take only the number. But if the value is negative, take both the sign and what? The value. So that means since this is said to be minus 7.5 here, we are going to take what slash minus 7.5. Okay.